Hello and welcome to episode 16 of Daryl Show Your Work. And in this lab, we're going to be using a variety of applications to look for suspicious files within a PCAP a file or a PCAP capture. So we're going to be using the application Zeek. We're going to be using a Wireshark, and we're also going to be utilizing Virus Total in order to see if we could find anything malicious. So the first thing that I'm going to do here is I'm going to switch to my desktop. All right, so just to give a brief background case of anyone watching has not heard of a Zeek, it's a free and open source software network and analysis framework used to provide deep insight into network activity by generating detailed, high fidelity transaction logs of network data. So pretty much what that means is we're going to take a PCAP file and we're going to break it down into smaller logs, and I'm going to show us how we're going to do that. All right, so sorry, give me a moment here. Okay. All right, so I'm first off I'm gonna tell Callie that I want to use Zeek, and I'm gonna use dash R, and I'm going to tell it I want it to I wanted to use, matter of fact, let me do this so we can see exactly everything that's going on here. So I'm gonna move this out the way because there's something on my desktop that I want you to see as I'm doing this, and then I'm gonna go back full screen on you. All right, so I'm gonna say covertchannel.pcap. All right, so I want you to pay attention to the left side of my screen and see what happens to the desktop here. So I'm gonna hit enter, and as you can see, on the left side of my screen, several logs generated. So what happened was Zeke took the information that was in the PCAP file, which is a packet capture. Okay, we saved a packet capture from Wireshark, and it took that down. It took that information and broke it down into smaller logs. So we have the a packet filtering log. We have a DNS log just for anything found utilizing port 53. We found files log that tells us any files associated with any traffic that was in a PCAP file. http log, which is anything utilizing port 80, connection log, which just gives us the communication between different IP addresses, and I'm not quite sure what the PE log is, to be truthful with you. All right, but we won't be utilizing that for this lab. So for the purposes of this lab, there's only a handful of these logs that are going to be relevant. So the first thing we want to do is we want to be able to see a detailed view of the different connections between all IP addresses, and we want to be able to see what ports were used and the duration of those communications. So in order to do that, I'm going to save us some time. I already have the command written out, and I am going to paste that into here. So again, we don't have to worry about any sort of syntax errors or anything of that nature, and save us a lot of time with me potentially fat fingering anything. All right. So give me a moment to paste that in here for us. All right. And I'm going to break this command line down for us. So I'm telling Zeke to cut this specific information from the connection log. And the information I'm asking for is the originating IP and the responding IP, the originating port and the responding port, and the duration of those connections. So I'm gonna hit enter, and as you can see, it gave me back the exact information that I wanted. So here is the here's the originating IP address. We see 129. We see that 129 is very prevalent here on this list as far as the amount of communications that it's making. And then these are the responding IP addresses that it's communicating with. And here are the ports that is communicating with. So we have port 53, we have port 80. All right. And then we also, if you look further down here, we see we actually have an IPv6 IP address. So right now, for those who don't know, the majority of IP addresses being utilized out there are IPv4. IPv6 isn't as utilized right now as IPv4 is. But let's say we wanted to we wanted to look at our PCAP file. We wanted to take these logs, and let's say we did only want to see IPv6 addresses. Well, a way to do that, if you look here, you have right here 546, which is a port, and 546 is commonly and 547 is commonly used by IPv6. So there's a good chance that if you were to narrow down a search for port 546 or a port 547, if you were to narrow those down in your query, that it would be attached to an IPv6 address. So let's try that out. And again, I'm going to plug that command in here and break down what's going on. All right, so similar to last time, I'm asking it for the same information, the originating IP, the responding IP, originating port, the responding port, okay, and then the duration of the communication, which we can see over all the way on here on the right. Just the aligning of this at the top is just a little off. Um, and then though, what I've added to the line here is I've told it to pipe and then pipe it out and then to grep that. And what I'm grepping here is 546. So I'm telling it basically anywhere in this information that you output where there's a 546, only show me that information. All right. So let's see if what I said about the IPv6 IP address is true, and I'm hit enter. All right, and as we can see, 546 is highlighted. No other record came up because that is the IP address that excuse me, that is the port that is aligned to the IPv6 address. But I could honestly put in any of these ports, because if I were to do the same thing here and I would change this number to let's say 137, right? All interactions, any place there's a 137. I'm gonna hit enter. All right, seeing we only get these two lines because these are the only two lines where there's an interaction with port 130 137. And it's also quite possible if there was like a 137 here in the IP addresses, it would bring those addresses for it too. But we would still get the information that we wanted because we would be looking at the specific port category as far as what it is that we're looking for. So it's still a good way to narrow down information and to look at certain parts of the traffic that we want to look at if we wanted to look at traffic based on port. All right, so if we're looking for specific types of activity, anything that's indicative of a threat, what we typically want to know, if we know that, let's say the machine that is on a 192, 168, 153, 129, let's say we knew that machine had a Windows operating system. Okay, so what we could tell Zeek is to look for a specific method associated with this addresses activity. And a method is either a get or a post command. So a get is usually associated with someone from that address trying to download something from the other address, and a post is someone from the originating address trying to upload something to the other address that is communicating with. So we want to look for those type of activities since we see a high volume of activity coming from 192, 168, 153, 129. We want to be able to see, hey, is there any sort of get or post methods associated with that to help us, to further narrow down that, hey, is there any sort of malicious activity going on here? All right, so I'm going to post um, that command in here. So to further break that down, all right, so now I'm telling Zeke to cut from the HTTP log. We're working with a different log now, and again, we want it to give us the originating host or the originating IP address, the originating port, the responding host, and the responding port in the duration of the connection. And now not just the method, the get and the post, but we also want to know any URLs that is associated with the get or post message, a post method. So meaning that any sort of a web address that may be associated with it, that may have been visited there, or that may be associated with um, um, the destination IP address. So I'm gonna hit enter. All right, so it returned to us the information that we were asking for. So we look here, we see a bunch of get methods from 129, okay, and it's going to these various IPs. And most of these destination IP addresses, they all look very similar except for one, and that is on line 3 here, which the address is 206, 188, 192, 204. And so we look at where it is that these destination addresses are taking us to. And so we look on all these other files, they're just HTML, JSON, CSS, cascading style sheet, HTML4, which takes you to a 404 error page. But there's one in specific that stands out, and this is the supercalc.exe. So exe is an executable file, and that should be something that's very concerning because most malicious payloads come in the form of executables, EXEs. So let's not just assume that, well, the person was just downloading just a calculator, because it could be a Trojan. It could be a malicious file masquerading as something benign or helpful, where indeed it may be malicious in nature. So if let's say we wanted to dive a little deeper into this, let's go into Wireshark and let's look at some of this traffic within there, and let's try to see if we can pull anything from Wireshark that would be any sort of assistance to us. So I'm already in root, so there's no reason for me to do a sudo on my command line. So I'm gonna just jump right into Wireshark, all right, and then I'm going to tell Wireshark the um, the file that I wanted to boot up with, which is our original pcap file. We're not using the logs anymore. We're using the pcap file, since that's what Wireshark reads, and pcap is short for packet capture. All right, so I'm gonna hit enter. You know what? I still managed to fat finger some stuff here. Okay, so let's try that again. I'm gonna exit out of Wireshark. All right. Okay. All right. Let's try that again. Except let's add a T to our file name. All right. So, all right, here's here's our PCAP files. As we can see, there's a lot of traffic in here. So, in order reduce this traffic down to what it is that we just want to see, really all we want to see is traffic going from 192, 168, 153, 129 to 206, 188, 192, 204. So, in order to do that, I'm going to apply a filter here, and oops, excuse me for that. Wireshark disappeared on me. All right. I'm going to apply a filter here inside of Wireshark. All right. So I'm in this filter, I'm saying IP address, which is the original IP address. I want it to pull communication between 192, 168, 153, 129 and 206, 188, 192, 204. Here's the syntax of how to apply that filter just to view traffic between those two specific IPs. And the ampersand is what ties that together. So I'm gonna hit enter here. All right. So we have our traffic going on just between those two IP addresses. As we can see, we have some TCP packets going, some HTTP packets going, which is not surprising because you can see right here the get command. I'm gonna scroll over a little bit. Get supercalc.exe. So that tells us that indeed that this was downloaded by 129 from this address. All right. So what we want to do then, let's see if we can find this actual file. So I'm gonna go down to export objects and then over to HTTP since that is the port that we're interacting with. All right. So right here, this is the file. So I'm going to save this file to my desktop. All right, so it's saved there. So the next thing I'm going to do, I want to find out if this file is indeed malicious or not. But I don't want to necessarily fire it off on my end. So there's a way that we can do that by using a online tool. All right, I'm going to show us where we can go. www.virustotal.com. All right. So what Virus Total does is what you could do if you want to investigate any sort of suspicious file or any sort of suspicious URL before clicking on it, or search even by keyword. You can bring those elements here, and Virus Total will compare what it is that you're entering into its databases. So what we're going to do, we're going to be utilizing the file method by uploading the file here to virus total. And what virus total would do is compare the hash of that file against the hashes in this database to be able to come back to tell us, hey, is this something that we have in our database that's known to be malicious? All right. So I'm gonna hit choose file. I'm gonna choose supercalc. All right. So I've uploaded that. All right, so we have quite a bit of flags here. All right, so here's the hash of the file. All right, let me see if I can zoom in a little for us. Maybe I can, maybe I can't. All right, well, anyway, yeah, this is the hash of the supercalc.exe file. So this is what it's taking and comparing it against its database with. So here we have several flags, and this is the malware that it is associated with. So this would be pretty much a given that this is malicious. This is a malicious file, and something that needs to come off your network, and perhaps that machine even needs to be isolated and quarantined. So it's just showing you the hashes associated with this with this file. So apparently it's using a SHA-256 a hash algorithm as far as the file that we uploaded. All right, and then clicking on some more tabs here, it just shows us um, different type of things with this behavior. Scrolling down here, has a section here where it tells us, what it does according to these tags according to the MITRE ATT&CK framework. It's TDPs, or attacks and techniques. And so that is pretty much it. So I mean, what we did here in this lab, we were able to take a PCAP file, we broke it out into smaller logs, we analyzed those logs to dive deeper into our network traffic to be able to see if we could find any IP addresses that had any sort of abnormal behavior to them. We saw that our .129 address indeed had a lot of outgoing traffic to different IP addresses, and then we saw one IP address in general where it looked like it was downloading the supercalc.exe file. So we went into Wireshark. We deduced where to find that file. We downloaded that file and uploaded it here to VirusTotal for further analysis, which indeed confirmed what we suspected, and that this was a malicious file. So please like, subscribe, share, and most importantly, show your work. And until next time, take care of yourself and God bless.